So this is the lesson for 6-1, day 1. So what the kind of questions that you're going to have today, we are still solving systems algebraically, but every question will involve fractions or decimals, all right? We don't want to work with fractions or decimals. Could you? Sure, you could, but fractions and decimals are a lot harder to work with, all right, especially when you're solving systems. So it's in your best interest to change the decimals and fractions into integers, into whole numbers, non-decimal numbers. The way that we're going to change a decimal into an integer is by multiplying by a power of 10. If you have one decimal place, if you have one decimal place, which means that you have a number that's in the tenths. If you have one decimal place, we are going to multiply by 10 to make it into a non-decimal number. So if we take this 0.4 and we multiply it by 10, now you're going to multiply the whole entire equation. That's why you're going to see me putting parentheses here. 10 times 0.4 gives me an integer of 4. 4 is a lot easier of a number to work with than 0.4 is. If you have two decimal places, right? If we have two decimal places, like this second one, 0.25, what we're going to do to change it into a non-decimal number is that we are going to multiply by 100. So to get rid of those two decimal places, we have to multiply by 100. 100 times 0.25 gives us 25 as an integer. 25 is a lot easier to work with in these problems than 0.25 is. Negative numbers work the same way. All you're doing is looking at the number of decimal places. If it has one decimal place like this one is, we'd multiply by 10, and you would end up with -8. -8 is easier to work with than -0.8. In this third one, we have 3 decimal places. If we have 3 decimal places, we are going to multiply by, you could probably guess, we are going to multiply by 1,000. That 1,000 gets rid of those 3 decimal places. So we have 1,000 times -0.125. When you multiply those together, you get -125. So the number of decimal places determines what you're going to multiply by to change your decimal into an integer. If we had a problem that looked like this, all right, just taking a look at this first one, all right, just taking a look at this first one, we have a 0.4, we have a 0.3, we have a 0.1, and we have a 0.2. This one is already an integer, so that one's great. What we want to do is we want to look at each equation individually, all right? So just looking at this top equation, my biggest number of decimal places is 1. Therefore, I would want to multiply this top equation by 10. Just like we did before, you want to distribute, distribute, and distribute. Now, even though this last number is not a decimal, we still have to distribute it by the 10. So when you go and do that, 10 times 0.4x is just 4x. 10 times 0.3 is 3y. And then 10 times 1 is 10. So that top equation changed into 4x plus 3y equals 10. This bottom equation, I have one decimal place and one decimal place. So I'm going to multiply this whole entire bottom equation by 10. Again, distribute and distribute. 10 times 0.1 is 1y. 10 times 0.2x is just 2x. These equations are easier to work with than those equations. Now, there's some of you that might be thinking, could I have I can see that I would need to multiply this bottom equation to make my opposites with my y's. I would have to take this bottom equation and multiply it by -3. So that I would have -3 times this bottom one to be a 0.3 and a -0.3y. Could you do it using the decimals? Sure. The process is just a little bit harder, which is why I would encourage you to make them into integers first. We're not actually going to solve that one. Take a look at the second one. Again, in the second one, you have decimals. We want to treat each equation individually. You don't have to multiply both equations by the same number. So when we take a look at this top equation, we have one decimal spot, two decimal places, and two decimal places. You have to multiply by the biggest number of decimal places, which in this case is 2. So we want to multiply by 100. Yes, that first one, it only has one decimal place, but in order to get rid of both of the decimal places, we have to multiply that whole top equation by 100. Distribute, distribute, and distribute. When you go and do that, you get 230x minus 525y equals 275. For the second equation, I have no decimal places, one decimal place, and two decimal places. So I'm going to multiply this second equation by 100 as well. Now, if this bottom equation, let's say that this 5 wasn't there at the end and it just said 10.2, we would just have to multiply the bottom equation by 10. You don't have to multiply both equations by the same number. So here I would take and distribute, distribute, distribute. 100 times 5x is 500x. 100 times 6.2 is 620y. And then 100 times 10.25 is 1025. Notice that all of my decimal places are now gone. These numbers, these integers, are a lot easier to work with. So let's take a look at what a question actually looks like. Now, when I take a look at this one, we're actually going to solve this one. When I take a look at this one, I notice right away, because I'm good at mental math. Some people are good at it, some people aren't. I know that I would just have to multiply this bottom equation by 6 to make opposites and have a 1.2y and a negative 1.2y. If you wanted to solve this problem that way using the decimals, you can. It's just a little bit more complicated of a process. What I would actually do here is I would get rid of all of my decimals. All right, we can get rid of all the decimals. I have one decimal place across the top. So I'm going to distribute, distribute, and distribute with my 10. So this top equation is going to turn into 15x plus 12y equals 6. And my bottom equation, I have one decimal place, and no decimal places. So I'm going to multiply this bottom equation by 10 as well. Distribute, distribute, distribute. So I have 8x minus 2y equals 20. Now it looks like a question that you had on your quiz. All right, I see a 12y and a negative 2y. Well, just like we did before, we would have to make opposites with one of the letters. I'm going to make opposites with my y's. Distribute, distribute, distribute. So I'm going to still have my 15x plus 12y equals 6. But now after I distribute, 6 times 8 is 48x. 6 times negative 2 is negative 12y. There's my opposites. And 6 times 20 is 120. Now I have my opposites. I have my 12y and my negative 12y. So now I'm just going to solve this problem like I normally do and add going down, because these 12y's will cancel out. Go ahead and finish this one on your own, please. Go ahead and finish this one on your own. So the first thing that we want to do is add going down. After you solve for your x, make sure that you sub it into your y. When you go to sub it into your y, you should really sub it into the top equation, or the top set of equations that have your decimals. But it would not be wrong if you subbed it into the ones that you made into integers either. All right, so really you could technically sub it into any of those four equations. So adding going down, 15x plus 48x gives me 63x. 6 plus 120 gives me 126. Divide by 63. Divide by 63. You should have gotten x equals 2. Now that I have my x equals 2, I can take this x equals 2. I can sub it into here or here for x, or here for x. All right. Technically, you really should sub it into one of the original equations. All right, so I'm going to sub it into that first equation. So instead of 1.5 times x, I have 1.5 times 2, which is my answer, plus 1.2 y equals 0.6. So multiply this out. I have 3 plus 1.2y equals 0.6, minus 3 minus 3. So I have 1.2y equals negative 2.4. Divide by 1.2, divide by 1.2, and you should have gotten an answer of y equals negative 2. Questions on this one? So that's what you're going to do when you have decimals. Now, fractions are a little bit more complicated. All right, fractions are a little bit more complicated. What we want to do with the fractions is we want to change them into integers again by multiplying by the lowest common denominator. Now, sometimes they call it the least common denominator. Sometimes they call it the lowest common denominator. Common denominator means that you are going to count by that number. All right. Lowest common denominator, you're going to count by that number. So if I take a look at this expression, 1/2 x plus 3y, if I was going to find my lowest common denominator, I need to count by twos, 2, 4, 6, 8, 10. I need to count by fours. Remember, we're looking at the denominator, so the bottom number. 4, 8, 12, 16. I want the lowest common denominator. Well, my lowest common denominator in my list of counting by the denominators is 4. So I would want to take this equation and multiply, or expression, and multiply it by 4. Distribute again. Now watch what happens. I end up with 4 times 1/2. 4 times 1/2. Now really this is 4 over 1 as a fraction. So top times top when you multiply fractions, bottom times bottom when you multiply fractions. 4 times 1 is 4. 1 times 2 is 2. Well, what is 4 divided by 2? 4 divided by 2 is just 2. So that's just 2x. When I take and multiply here, I'm doing top times top. So I'm doing 4 times 3, bottom times bottom, 1 times 4. So I end up with 12 over 4y. Well, 12 divided by 4 is 3. So think about what you would really want to work with. Would you rather work with 1/2 x plus 3/4 y? Or would you rather work with 2x plus 3y? 2x plus 3y is a lot easier to work with. So what we did there was I wrote out my list of denominators. I'm counting by the denominator. So I counted by 2's, I counted by 4's. I then found the lowest number that they had in common. That lowest number that they had in common was 4, and I multiplied that whole expression or equation by that number. So take a look at this one. We have 3/4 x plus 5/6 x. I'm going to count by 4's, 4, 8, 12, 16, 20. I'm going to count by 6's, 6, 12. I could stop right there. Ding, ding, ding. They have a 12 in common. Since they have a 12 in common, that's what I'm going to multiply by. Distribute, distribute. So remember, this is really 12 over 1. So top times top, bottom times bottom. 12 times 3 is 36. 1 times 4 is 4. So 36 divided by 4 is 9. So that becomes 9x. Top times top, bottom times bottom. 12 times 5 is 60. 1 times 6 is 6. 60 divided by 6 is 10. So again, what would you rather work with? Would you rather work with 9x plus 10y or 3/4 x plus 5/6y?
Are they always going to be like a one number difference?
No, they might not be. All right, they might not be. Our next one is not going to be. All right, take a look at this next one. All right, I'm just going to draw a line here to sort of separate. So in this next one, we have 6's and we have 8's. All right, we have 6's and 8's. So I want to count by 6's, 6, 12, 18, 24, 32. I want to count by 8's, 8, 16, 24. So this one has a 24 in common. So that's what we want to multiply by. We want to multiply by 24 and 24. And again, that's really 24 over 1. So 24 times 5. Let me get my calculator here. Sorry. 24 times 5 is 120. So we have 120 over 6. 120 divided by 6 is 20x. And then we have 24 times 3. 24 times 3 is 72 over 1 times 8, which is 8. 72 divided by 8 is 9. So that becomes 9y. So we have 20x plus 9y. So let's take a look at what the equations would look like with these. So again, you don't have to multiply the top and bottom equation by the same number. So look at this top equation. So we have a 2 and a 4. So 2, 4, 6. Well, I don't even have to go very far on this one. Counting by 2's, I'm counting by 4's. They have a 4 in common. So I want to multiply this top equation by 4. Distribute, distribute. Make sure that you distribute that third time. That's the biggest mistake that people make. So this is really 4 over 1. Top times top, bottom times bottom. So I end up with 4 over 2x. 4 over 2 is really just 2x. And then I have 4 times 1, which is 4. 1 times 4, which is 4. 4 divided by 4 is 1. So I have 2x plus 1y. 4 times 6 is 24. So that's my top equation. I would not have to do anything with this bottom equation in this particular question. There are no fractions there. So these two would be my two equations. Let's take a look at this one. In this top equation, we have 3's and we have 5's. So I want to count by 3's and I want to count by 5's. 3, 6, 9, 12, 15. And then here I have 5, 10, 15. So I have 15 and 15 in common. So I want to multiply this top equation by 15. If I take a look at my bottom equation, I have 4s and I have 6s. So I want to count by 4s and I want to count by 6s. 4, 8, 12. I know that I could stop there because when I go to count by 6s, 6, 12. So I want to multiply this bottom one by 12. When you would distribute, you would end up with an answer on the top. You would have 15 times 2, which is 30. 30 over 3 is 10x. You would have 15 times 4, which is 60. 1 times 5, which is 5. 60 divided by 5 is 12y. Make sure you distribute that third time. When you distribute that third time, 15 times 10 is 150. For the second one, 12 times 3 is 36. 1 times 4 is 4. 36 divided by 4 is 9x. 12 times 1 is 12. 1 times 6 is 6. So 12 divided by 6 is 2. So we'd have minus 2y. And then 12 times negative 2 is negative 24. And then we could go and solve the problem from there. All right. We would make opposites with our y's. I would multiply, if I was going to solve this one, I would multiply this bottom equation by 6 because I'm trying to make opposites with my 12 and my negative 12. So go ahead and try to make, just do the equation part. All right, just make the equations for these two. All right, try this one on your own. Go ahead and try and make the equations for these, please. In this top one, we have 4s and we have 2s. So I want to count by 4s and I want to count by 2s. 2, 4, I could stop right there. All right. So I'm going to multiply this whole top equation by 4. Now it's not just 4, it's really 4 over 1. So we need to distribute, distribute, distribute. When I go to multiply those out, I have 4 times 3 and 1 times 4. So I have 12 over 4. 12 over 4, 12 divided by 4 is really 3 over 1. So that changes into a 3x. I have 4 over 1 times 1 over 2. Top times top, bottom times bottom. 4 times 1 is 4. 1 times 2 is 2. So I have 4 over 2. So that is just 2 when you divide. Again, top times top, bottom times bottom. 4 times negative 3 is negative 12. 1 times 4 is 4. Negative 12 over 4 is negative 3. So that's my first equation. For my second equation, notice that you have a 3 and a 3. Well, if I count by 3s and count by 3s, my lowest common denominator is a 3. So this one's a little bit weird. All that you're going to do is multiply by 3. And it's really 3 over 1. Distribute, distribute, distribute. Top times top, bottom times bottom. 3 times 2 is 6. 1 times 3 is 3. 6 over 3 is 2x. Multiplying by the middle one. 3 times 2, 1 times 3. You'd have 6 over 3. 6 divided by 3 is 2. So you'd have 2y. y. 3 times 2 and 1 times 3, top times top, bottom times bottom. 6 over 3 is just 2. So there's my two equations now. These equations are a lot easier to work with than these. Go ahead and solve the rest of the system, please. Now that we have our correct equations, go ahead and solve the rest of the system, please. So the next step that you would want to do, just like on your quiz, is to create your own opposites by multiplying. Go ahead and solve for both x and y, please. After you solve for x, you want to sub back in for y. Remember, you can sub it into any of those 4 equations. I like the bottom ones better. They're easier to work with. So when I take a look at this, I see a 2y and a 2y. I think that's really easy to make opposites with because all that you would have to do is multiply either the top equation or the bottom equation, it doesn't matter. Multiply by -1 because then I'd end up with a -2 and a +2. However, you could do this a totally different way. We could make opposites with our x's by multiplying them together to be 6. So I would want a +6 and a -6. So I could, if I wanted to, multiply by like 2 and -3. All right. If you did it that way, you would make opposites with your x's. Either way is fine to do it. There are multiple ways to do these problems. However, I think the easiest way is to multiply either equation by -1 to make our opposites with our y's. If we multiply with the -1 here, distribute, 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 I end up with -3x minus 2y equals +3. So now I have my opposites. I have my opposites right here. So now all that I need to do is add going down. When I add going down, those y's will cancel out. We have 2x plus -3x, which is -1x. We have 2 plus 3, which is 5. Divide by -1, divide by -1. And we get that x equals -5. That is one of our answers. I now am going to take it and sub it in. I actually like this equation to sub it into right here. That's probably the easiest looking equation to me. So I'm going to sub it into that one. 2x plus 2y equals 2. I'm going to take my -5 and sub it in for x. So 2 times -5 plus 2y equals 2. This would be -10 plus 2y equals 2 plus 10 plus 10. So 2y equals 12. Divide by 2, divide by 2. And we get y equals 6. So again, that's what you're going to have to do today. These get a little bit confusing at times. All right. So just remember that when you have the decimals, you can solve them like they are. But if they have 1 decimal place, you want to multiply by 10. 2 decimal places, you want to multiply by 100 first. So again, when you take a look at